Problem 2. Let's solve some more complex radical equations. What if we did not have a radical going on here with the equation, but what if that radical was expressed instead as a rational exponent, a fraction for an exponent? So look at this problem. What is the solution of 3 times the quantity x plus 1 raised to the 2/3 power? And that's equal to 12. See that little review box right over there? Does that look familiar? If I have any number raised to a power and then raise it to another power, that'd be equivalent to multiplying the two exponents together. For example, if we take, say, a to the third and raise it to the fourth power, isn't that really essentially the same as a to the third? A to the third, a to the third times a to the third, which ultimately is we're multiplying how many a's together? It looks like we're multiplying 12 a's together, which could be the same as us saying a to the 12th. Shortcut, multiply those two together, and we've got our answer there, right? Right. So when it comes to this problem, what is absolutely no different with this problem, even though there's a fraction right here, we still have this x plus 1 raised to this power right here. So our job still is to isolate that grouped quantity. So does it make sense that the very first step here is dividing both sides by 3, because that 3 is the only thing that's outside of that quantity being raised to the 2/3 power. Okay. Now, here's where this type of property comes in. If I have x plus 1 raised to the 2/3 power and equals 4, I could rewrite that based off of previous lessons, and I could say, well, it's actually the cube root of x plus 1 squared, and I could x plus 1 square it and square both those, and no, it gets to be a bit of a hassle. Here's what's awesome about us doing this type of move that you see right here. Let's raise each side to the 3/2 power. Now think about it. What is the connection, that math term between the 3/2 and the 2/3? Starts with an R, right? We know what that is. The reciprocals of each other. And if we apply this property right here and multiply those two reciprocals together, what's going to happen? You got it. You're going to get 1 right there. And if we're going to take x plus 1 and raise it to the first power, we're going to be left with x plus 1. Okay? And so notice what I did to the other side here as I undo a couple of these highlights here. We're taking that 4 and raising that to the 3/2 power. Now this next part takes a little bit of explaining. I get what they're trying to do here. Let me try to explain this to you in a different way, so that way we don't need to worry about absolute value bars here. Okay? Think of it from this perspective. Do you notice what just happened right here? We are taking 4 and we are going to be raising that to the 3/2 power. In other words, what is actually happening here is we are actually taking the square root of 4, right? And then taking that and raising that to the 3rd power. That's why we get the answer of 8. Now, because we are solving for a variable, it's very important to remember here too. When we solve for a variable, we are responsible for all answers. And think back to when we had a problem like this. If you were responsible for giving me all of the solutions of this isolated problem right here, suppose x squared equals 36, wouldn't there be 2 answers? And I told you not to forget about that plus minus sign, right? It's plus minus 6 would be the answer there, right? Well, these problems are no different, because to solve that problem I'm just erasing right there, we had to take a square root. Aren't we essentially taking a square root of 4? So rather than look at it from this perspective with this guy right here, when I have x plus 1 raised to the first power, which is really what that is, I'm going to have x plus 1. And then, because I am taking a square root here, let's put the plus minus there. So you might even want to ignore this type of statement right here too. Basically, this is what I'm saying. If there is an even denominator, then you need a plus minus sign with that answer. So square root the 4, you get 2, and then 2 cubed would be 8, so we have plus minus 8. So then to solve our problem, we're going to be subtracting 1 from not only a positive 8, which would give us the 7, but also subtract 1 from a negative 8, which would put you at negative 9. here's what's also extremely important to do. It's extremely important to check your answers, especially when you start getting more than one answer. Because sometimes we might get more than one answer, and more than one answer might not be the best recipe for success on these problems. So here's how I best recommend you check your answer. Use the calculator. It is the most this is fastest, the most efficient way of checking this answer here. So if I have 3 times x plus 1 raised to the 2/3 power, I need my answer to be 12. I have 2 possible answers here, 7, -9. Yes, Mr. Cook is talking very fast. Let's go to the calculator. So that problem again was 3 times the quantity x plus 1 raised to the 2/3 power. Do you notice right now I'm checking 7. Okay, so I put the 7 right there. Do you notice how I had to put 2/3 in parentheses? That's very important. Do not put that 2/3 in there without the parentheses. That's kind of a big deal. Okay, so let's check to see. Press enter. Sure enough, we get 12. Perfect. So that means 7 is a perfectly legit answer. What was the other answer? I think it was -9, right? So I'm lazy. I'm going to press just second enter to copy down my previous entry. And I'm going to shuffle back here to the 7. I'm going to hit not delete, but hit second and then delete, because now I can insert a negative sign there. I'm going to hit the right arrow to get the black boxes coming back there. I'm going to type over the 7 and just put a 9 right there. And if this works, yep, we get 12 here again. So both these answers work. We did it. We did it. We did it. Okay, so that works. Both those two answers are okay. Okay, so just watch out for when you get an even number there, because remember back to a couple lessons ago, you take even roots, there's 2 real answers, right? Whether it's a square root, a 4th root, a 6th root, whatever. But if you're taking an odd degree root, like if you take a look at this guy right here, and boy does this look familiar. Let me flip, flip, flip. Hey, look at this guy right here. Remember this one? Let me zoom out here a little bit. We just spent most of our time at the very prologue here doing this problem here. Okay? Key thing is isolate that 5th root of x plus 1 to the 3rd power. That's exactly what we did right here. And that's exactly what the textbook did, is they isolated that 5th root. And actually, well, the first thing they actually did is they rewrote that 5th root of x plus 1 to the 3rd, probably just to make it a little bit easier to read, which I agree with them. I like that move. Remember, roots are underground, so that 5 needs to be in the denominator, and that 3 goes up there. Then, and only then, did they start to isolate that x plus 1 to the 3/5 power by subtracting the 1, ba-boom, dividing by 3, ba-boom, and there's that predictable 8. And now they raised it to the reciprocal of 3/5, which is 5/3. And then do you notice here we didn't have to worry about plus minus? Here's why. Because it's a cubed root. Remember, with cubed roots, there is only one answer. Okay? So if it were me personally to do this work, I probably would not take the time and do this move right here that I did right here and rewrite 4 and 3/2 power and do the square root of 4 and raise the 3rd power. Folks, you got a calculator, use it. Let's just take 8 and raise it to the 5/3 power. And very briefly here, remember how I said parentheses are important? Here's why parentheses are important. The correct answer there should be 32. You do not put parentheses on that. Guess what it's going to do? You got it. It's going to take 8 raised to the 5th power, get that answer, and then divide it by 3. That's why you see that 2/3 there of that fraction left over there. So we want the 32. So make sure you put those exponents in parentheses when necessary. Okay? So that's why we have 32 right there. Last move, subtract the 1, boom, we get 31. Check that answer. Let's check that answer. Let's check that answer. So if it were me checking this answer, I probably would not check it from here, just because of all the gobbledygook that you get there with 5th roots. I would look at it in its equivalent form. I'd use this instead. Okay? So don't check it here, check it here. Okay? That way you can just use your calculator. What was the correct answer again? It was 31, right? We need an answer of 25. So let's go to our calculator. I'll skip over the typing in part. Alright, so take a look. Did I type that in there right? 3 times x plus 1 raised to the 3/5 power. And then plus 1. See how my plus 1 is after the parenthesis? Hit enter there. We get 25. And I believe that's right, right? Go back, check our answer back here. Yep, we needed 25. Kaboom. Great way to check our work. Alright, so now it's your turn. See this problem on the other side. You're going to have to flip your note sheet over. Alright, so think about what you should do first, and then from there, think reciprocals. We'll pause the video, give you a couple minutes to kind of plug away through this, and then we'll see how you did. Alright, so what's step number one here? Step number one, got to isolate that exponent first. And what was that exponent? It is the whole quantity, x plus 3 to the 2/3. So what guy is standing in our way here of isolating this is just the 2. That's right. So all we have to do here first is divide both sides by 2. We do that, now we have x plus 3 raised to the 2/3 power, and that equals 4. So now that we have successfully isolated that rational exponent, now to solve, let's raise it to the reciprocal. Both sides to the reciprocal. So what's the reciprocal here of 2/3? It would be 3/2. So we're going to raise both sides to the 3/2 power. Okay? So what happens on the left? On the left side, all that's left is that x plus 3 to the first power, right? And then we have that 4 and then 3/2. Now do you notice that the 3/2, see how there's a 2 down there? Because roots are underground, we are taking a square root here. So not only do we have 8 here, but we technically should have plus minus 8. So maybe Mr. Cook made a mistake here. Let's kind of keep following my steps here and see if I, oops, yeah, I'm one answer short here, aren't I? Okay. So let's see if we can fix that. What we should have here is, because we are taking a square root, we should have plus minus, and then we should have plus minus 8 right there. And so then our answer, after we then subtract the 3 from both sides, okay, we are actually taking, one of our answers would be what? 8 minus 3. And then our other answer would be negative 8 minus 3. So two answers that we could get here would be 5. And then the other answer would be negative 11. So now we need to check both of those two answers. So 5 and negative 11 need to get checked right up there. Let's make our graphing calculators check that answer. 5 and what was the other one again? Negative 11. Okay? Okay, so here's me checking 5. 2 and then parentheses 5 plus 3, raise it to the 2/3 power. There's our 8 that we needed there. Double check, make sure that that was 8 over there on that side. Yep. And then our other answer check, it was negative 11, so I'm going to hit second enter just to copy it in there. And then let's insert negative 11 in here, second, and then delete, and then hit the negative, and then 11. See how it just puts the 11 right there? And then I'm just going to press delete to get rid of that 5. Press enter, should get 8 again. Boom. Both those answers are legit. Too legit to quit. Yeah, yeah. Alright, I'll stop singing. So, there we go. That's how these problems work, ladies and gentlemen. Let's move on to the next problem set.